Today I'm going to talk about how to manage open source software security in your organization. I don't think I need to introduce myself because I've been properly introduced. I have been an open source enthusiast for 10 years now, so I think I know something about open source. And I come from Barcelona, but I am originally from Peru. So, open source. As you might know what open source is, it's source code that is publicly available, and it allows you to use it and then distribute it, right? We all know what open source is, and we most likely have used open source already. If not, I encourage you to use it. And open source is pretty much everywhere, right? From rockets going to the moon to Thermomix, right? And the reason is, well, there are several reasons, right? First, and probably one of the most popular ones, is that it's free and it's publicly available. Meaning that if you want to try out something, you don't need to get into any commercial agreement or look at budgets. You just jump into open source, write a small POC, and then get rolling. It's flexible, and it's mainly general purpose, because as opposite as what you do in your company, where you try to fit specific use cases for your company and your circumstances, open source libraries and packages are designed to be flexible, so more than one user can use it, right? But it's still flexible, so they will allow you to do your customization to fulfill your use case. They're usually stable and reliable. I would say usually, because there is an API contract behind it, and then there is a promise that the open source project won't break your system, right? And also, with the rise of things like SEMVer, semantic versioning, we have like a no-brainer option to say, okay, I can still use this without breaking my code. It fosters ingenuity, creativity, and innovation because it's specifically designed for you to build things on top of that, right? And then in many cases, it comes with a built-in community, right? People who devotedly will maintain the code, improve it, add in more features, and most likely give you support whenever you have any question over Slack, or GitHub issues, or GitHub discussions, or whatever, right? And it has shared maintenance costs, right? Among users, active users actually, right? Because one company will hire an employee working on a project that employee will spend time and effort putting up a PR, and then there is another guy, another person from another company reviewing that pull request, then there is another person cutting the release, and then publishing the packages, and so on, right? And mainly because it's the future. Because most of the reports are saying that we are moving towards more usage of open source, right? And now with the rush of the AI, we are delivering much more software. And that software runs on open source, of course. So yeah, we took these numbers from the Sonatype research. Then we will say that we have over 4 million of packages in the open source from the major package repositories from Java, JavaScript, Python, .NET, 60 million of versions, right? That's a lot. And pretty much according to Synapses on report of this year of open source usage, 96% of the code bases contained open source, right? And also 77% of all the code was originated from open source. So these are pretty solid numbers that show that we highly depend on open source, highly rely or system or revenue source from open source, right? But then there is this thing, right? Which you might have a very complex and very sophisticated project or system that relies on several pieces, and one of them might be like the weak part of the chain, right? Because there is this random guy who is maintaining this open source project, for example, Lodash, right? Do you remember Lodash? And then that makes, as they said, like the chain is as strong as the weakest link, right? So this is one of the problems that we have in open source. And if we look at numbers, because we also have bad numbers, you will see that every year we are solidly increasing the number of CVEs in software, which are mainly comes from open source, because proprietary code, you don't have that much access to that information. There is a solid growing over the CVEs records. And then this Synapses report also tells you that 84% of the code bases contain at least one open source vulnerability, right? And 54% has high-risk vulnerabilities in the past year. So there is an active threat on those using open source, because not everything or nothing comes for free, right? There are some risks. And one of the way to look at risk is mainly that the risk is the likeliness of something to happen plus the impact, right? In our case, the likeliness for open source project as opposite to, let's say, proprietary code, which is private mainly, versus open source that is open, and anyone could look at the code and say like, oh, there is a vulnerability here, right? Is higher. So there is this very nice curated list created by the OWASP, the Organization for Security, with the top 10 risks for open source projects, right? There are 10, 9 of them are actually actionable. The first one will be non-vulnerabilities, right? Because a version, a component, a specific version of a component might have a vulnerability. There are several reasons why you don't fix that vulnerability, or why you don't upgrade that library to a version that is not compromised. And it could be because you're using a very old version of this, and then changing to a newer one, which has the security patch, is hard, or because just you don't know, because it's not a direct dependency, but more like a dependency of your dependency, or whatever. This is one of the risks. Then the second risk is compromise of a legitimate package, right? Let's say you're an open source maintainer, and then your credentials get leaked or compromised, and then someone steals your identity in GitHub and push a malicious commit, retag the repository, and now your legitimate package is compromised. Name confusion attacks, those are really funny because they consist on people creating packages or organizations very similar to well-reputed packages, right? And then when you have a typo or whatever, it will just get into your source code. Unmaintained software. Remember the previous meme? Like you might depend, or your entire infrastructure might depend on a package that has been abandoned because the maintainer just moved it into playing music instead of writing software. Or just don't have time. Or maybe that person doesn't work anymore on the same project, so the package goes lost and forgotten. Outdated software is another problem, because you might be using an old version of a component, right? Not necessarily a vulnerable version, but an outdated version that hasn't gone through the scrutiny of modern technologies in terms of security, right? We also have untracked dependencies, because I don't know if you have seen a dependency graph for a project like Kubernetes, for example, which is a massive thing, right? With thousands of dependencies that you don't even know, because packages depend on packages and those depend on other packages, right? So it's very complicated to track down what are the dependencies manually, of course. There are automated tools, but you're not looking at them every day. License risk is part of this top 10, but I don't think it's actually actionable. It's more about a compliance thing, right? Because it's not about the vulnerabilities it's going to put in your code, but more about what are you using these packages for, right? So not necessarily a risk in terms of you will get compromised, but I wanted to mention it. In mature software is something really interesting that we have seen over the years, because now with explosion of new standards, open tracing, open telemetry, the so-called zero-dot versions where people are trying to design something new and they don't have the final design, so they keep releasing zero-dot versions. Components are not stable. They will introduce breaking change on every new version. And not necessarily only that, but maybe they're just starting with it, so security audits are not in place because, they're just starting with it. Sometimes security is an afterthought, right? You don't even look at security at the beginning because you want first your project to succeed. On approved change, right? Because you could be in a situation where there was a change, a potential change with, that will compromise your infrastructure into a library, and you don't know about the change because you're just relying on a stable tag, right? But not everyone looks at the changelog every time they upgrade a dependency, or not a changelog version by version, right? So it's hard to track that. An under or oversized dependency, right? Because you might depend on a component, for example, Lodash, right? Lodash is basically, it provides you, or leftpath, for example, right? That it's a library that will allow you to path on a string with certain characters. Do you need a library for that? Maybe yes, because it's your business to path in strings. Or maybe not, and you could design something inside or in-house because your use case is very simple. So these kind of things you have to balance, right? Or maybe you include a package that is huge and massive with thousands of APIs, and you only need one, right? So do you want to compromise yourself with this? I don't know. So let me present some strategies for securing your open source usage. First, I will say we should maintain an inventory of open source software in use, right? Because you cannot protect what you don't know or what you don't see, right? First, you define policies on how to choose a package, right? How to monitor its health over time, because a package might be suitable for you now, it might be well maintained now, but not tomorrow. For example, the open source software or Open Source Security Foundation has a very well curated scorecard, which has a checklist to say like, okay, this project fits. The maintainers have multi-factor authentication. They have a security form to report vulnerabilities. Or they have active, or they have, the contributors have been active over the last months and so on, right? That's a good one to assess the health of a project. You have to define explicit policies in favor of do-it-yourself when it makes sense, right? When you don't want to use a library that is just for one thing. And don't reinvent the wheel as well, right? Because you might have like, why would you, for example, if you think about a simple case like it's a cache, in-memory cache, right? You might think, yeah, I just have a map with access by key. If my use case is as simple as that, I will just build my own map. But then if you have to deal with concurrency, you have to deal with memory because you don't have a fixed size of the cache, and then you have to constantly be cleaning up the cache and all that. You don't want to reinvent that. That's already written, right, by someone and maintain it because it was used across the internet, right? Automated analysis, because manual analysis is impossible, right, of the supply chain to identify dependencies and build dependency graphs. So you can have, whenever there is a vulnerability, you can say like, okay, am I using this package or not? And how? Is this service tier 1? Is this service critical or not? Should I action right now or should I wait? Maintain up-to-date SBOMs. SBOMs are somehow controversial to me because SBOM can tell you, okay, what libraries you use, but there is some room for having false positives because not necessarily tells you what are exactly the functions that you're using, and are those functions vulnerable, right? It's definitely better to have a SBOM over not having it. But it has to be combined with other techniques which actually tell you and narrows down whether the vulnerability, or you're affected by the vulnerability or not. But in general, it's a good thing. And get involved with crucial projects being used in your systems, right? Don't be that company, of course. Because most of or not most, but many companies get benefit from open source. And it's a good thing to think about whether should I contribute back or not, right? In general, you should. I encourage you to do it. So other strategy for protection, ensure that open source is secure, right? There are several measures you can leverage for that. And then there are different ways how you can approach the risk of the vulnerabilities, right? You can watch the news, get to the office and say like, hey, there is this vulnerability that has been released on this library that I think we use, let's fix it. Low cost, but low assurance, right? Or checking for public vulnerabilities like CVEs and then match with your dependencies. That's a good strategy. Still low cost, low assurance, but better than just watching the news. You can also purchase like commercial databases for CVEs, which is one level deeper, but then you encounter this dilemma where you might find some false positives. So, okay, it's better than the previous version, the previous option. You can purchase curated images if you're using Docker, for example, right? For example, you can go for distroless or a commercial distribution which promises as zero as possible CVEs. That's a good baseline for you to start. You can use tooling to detect CVEs in your dependencies. There are a lot of tools that will analyze your source code and then match against these databases automatically and trigger alerts in your CI or just trigger alerts on Slack. Or you can choose to perform an in-depth security reviews, right? Which has higher cost, but also the return of investment is higher. What will you be looking for will be public vulnerabilities, of course, in an automated way. You will run a static analysis, like analyzing your source code and looking for vulnerabilities. Dynamic analysis, because you cannot catch everything statically, right? Sometimes you have to look at the runtime, right? There was this library that on Bootstrap, it was pulling a database from S3. If that library gets compromised, you won't find anything statically, but you will, if you do the runtime analysis, you will detect that it was pulling information from a compromised bucket. Or at least acknowledge that, right? Secure configurations, right? Saying, okay, I will only expose these endpoints to the internet. I will only allow you to ping these ports when you are in the same network or whatever. This kind of secure configuration measures are good. Code review, right? Because you have to do a lot of code review with the security hat on. Whether you are a software engineer or a security engineer, it's very important that you carefully review the pull request. Project health, tracking project health is important, as I said, because you don't want to rely your entire business into something that is unmaintained. An active monitor of all these outcomes, right? Because there is this nice quote saying that you can apply all these configuration settings that are secure and hope for the best. But hope isn't a strategy, right? You have to actively monitor of all these outcomes every time to see when there is a deviation, there is something suspicious, and all that. Applying this doesn't guarantee that you are safe. Monitoring it is a best effort to be on top of it. Then C, respond to security vulnerabilities. Those numbers are not, of course, not official, right? There is no database saying 99% are routinary, but 90-something, right? Teams get alerted, and when vulnerabilities are found, they can be patched manually or automated, right? Dependabot, Renovatebot, they do that for you, Sneak, right? Those are the easy ones. You don't even need to do anything. Just click the merge. But then there are the intricate ones, right? Remember, for example, Log4Shell, right? Because sometimes understanding, so one thing is knowing that there is a vulnerability, then understanding the vulnerability, fixing the vulnerability, and rolling out the solution. That's like a long way. So first, it requires triage, and you have to identify the affected components. You will roll out mitigation if possible. Sometimes it isn't possible, but for example, if in Log4Shell you could roll out a WAF rule, and then that will avoid certain traffic that will exploit the Log4Shell until the actual solution comes in, right? Or if there is a vulnerability that will trigger a DDoS, you can roll out rate limiting. That's a good mitigation. But not always you have mitigations available. Then you coordinate a solution, which could involve you to contribute to the open source project, right? What a great thing. And then you finally roll out a solution, which could take weeks because you might need to upgrade libraries, and then maybe you have to introduce breaking changes, or there is this, let's say, component that people who created it already left the company and there is no clear ownership around that, or no expertise, or nobody wants to, or it will take time to review it, or the change will affect the different components in your system. So it's not that easy. But luckily, they are just the 1% or something like that. So, conclusions. First, you have to keep an accurate inventory of the open source that you use. Please, automation is essential. Don't do that manually. Don't even try it. Use high-quality vulnerability data sources, not only CVEs. You can also use tools that have their own commercial databases for vulnerabilities. That's also a good one. Leverage existing processes to respond to open source software vulnerabilities. Don't just wait for the time to come and then everyone is in panic. Do not rely on a single layer of defense, right? Unlike life, where less is more, security, that doesn't work. Less is less, more is more. So have different layers of defense in your security strategy, like not only static analysis, but dynamic analysis, but network policies, but web application firewalls, right? Consider adopting practices that keep open source components up to date. Again, automation is crucial here because that could be a massive work. And stay on top of the open source supply chain, right? You need to monitor what is happening, what are the alerts being triggered, and then action them, right? Don't just put the configuration in place and hope for the best. So you can reach me out in case you have questions. I will be happily be in touch about open source, security, or whatever. These are the references that you can read if you are interested in learning more about open source security. And yeah, thank you. You have questions? I am here.
Thank you for the presentation. Very precise and pragmatic advice there. So thank you so much.
Thank you.
Question for you. It's one thing to identify vulnerability for OSS. It's a whole different ballgame for remediation and mitigation. And you had some advice around, web application firewalls, rate limiting, patching. But what if there is a vulnerability on an open source library, there is no clear path for upgrade? There may be, given the amount of the application, that code might be dependent on that library, and it's like a huge endeavor to just replace and go to another equivalent library that provides similar functionality. Do you have any advice on a library that does not have a clear upgrade or clean upgrade?
Yeah, so thank you. Thanks for the question. So there are two things here. If changing a library is definitely something that brings a lot of uncertainty in general. Because although the library you have might have some vulnerabilities that will require upgrades or whatever, changing a library to something else, unless that library is solid library, well documented, has benchmarks, and has design documents that explains the caveats and the trade-offs, I will suggest to see the feasibility of you fixing the library instead, and porting. There are several companies that maintain forks of their own, of existing libraries just to add the security patches based on commercial databases or on CVEs, right? So I will advise to first try to fix what you have because that brings less uncertainty versus doing big bang changes, which will represent introducing a new library that you don't know yet, unless it's something bulletproof.
Hi. So you had said that SBOMs are a little bit kind of controversial, and I've had some conversations with developers about them as well, where It's almost like on one hand, like the hardcore developers, like the whole concept is flawed. I mean, it's very compelling on one hand to have this ingredient list of what's in your your product, but with all the dependencies and then like sort of feature accessibility within a library and all these other kind of wrinkles, I guess, how, from your perspective, because you've clearly thought about this a lot, do you see SBOMs playing out as you have places like CISA requiring or encouraging the government to require them for all sort of manufacturers selling to the government, et cetera? I then have 100 SBOMs as a CISO or whatever, a consumer, like what do I do with them and where's this all going to go? Like, just talk a little bit about how you see the future of SBOMs.
Yeah, so yeah, definitely, as I said, having SBOMs is better than not having them. The way I see them is more like compliance thing, right? Because there are requirements that require you to have a list of ingredients for the software. But if you really want to get into something more concrete and say like, okay, I want to really know whether I am vulnerable or not, despite this SBOM that will tell you you are using this library and it's vulnerable, there are now runtime-oriented alternatives. We'll look into, or we'll get into your binary and in runtime detect what are the functions that you are using, right? Think of it like, for example, in WebAssembly, right? In WebAssembly, it's a binary format, but if you turn into the text format, you will see all the functions that you are importing. And then you can actually say like, okay, I'm using this function and this function is vulnerable. You cannot do that in other binaries, but or in other artifacts out of compiled languages. But in runtime, you can inject hooks to say like, okay, I'm using exactly this function and this function is vulnerable. Then I will action that, or I am not vulnerable because although I'm using this library, I'm not using this function. Then I decide to skip the risk. Can't remember exactly the name of that. It's something around Vex, but there are already 2-3 libraries doing that you can hook that instrumentation already into the binary, into the runtime. So for me, I am a big fan of, although static analysis, I recognize it as an extremely important thing. I'm a big fan of runtime analysis, right? Whatever information you can collect from runtime, like with production traffic, right, within the real environment, that I see something much more, let's say, expensive to get, but gives you much more insights about what is happening in your application. Yeah, but a really good question. Thank you.